Hey guys, today we're going to be working on graphing quadratic equations, also known as parabolas. As with the last couple of topics, this may be a review for you, it may not. We're going to be looking at three different types of equations, or I should say three different forms of equations. But I want to review or introduction to graphing parabolas, and we'll use that in 1.4 when we start working with systems of nonlinear equations. All right, have a good one. Review real quick the different parts of a parabola. First off, what we have here, and I'm not focusing on the numbers at this point, just the spots. First off, the x-intercepts. So this right here is our x-axis. Most of you hopefully know that one, but if not, that's why I'm going over it. And then we'll go green for the y, whoops, wrong one, for the y-axis. So our x-intercepts are going to be found where our parabola crosses the x-axis. So here we have, you can't see where I'm pointing, sorry. Here we have the point 3, 0, and over here we have the point -2, 0. So those are our two x-intercepts. Again, not real focused on the numbers, especially with the vertex today. The next thing, the y-intercept, where it crosses the y-axis. So right there, where that crosses, that's going to be the point 0, -6. That's our y-intercept. And lastly, also very close to the y-intercept, unfortunately, is the vertex. The vertex is the lowest or the highest point on the graph, so it's where it turns around. And that's a big focus of what we're going to be doing today, is finding that vertex and building the rest of the parabola around it. One thing I do want to note is that anytime you're given any type of equation, you can always set up an XY table. So given any any equation, you can pick some points for x and y, plug them into that equation. Actually, I'll come back to that in just a little while. That's not super helpful right at the moment. Moving on that much. Okay, so we have three different forms of our equations that we're working with. And it's best to know each, because in each situation, whether we're dealing with graphing vertex form, you'll hear it both ways, factored form or standard form, there's a method for finding the vertex that's going to be easier with the other ones. In any case, factored form can be multiplied out to put in standard form. Standard form can sometimes be factored to put into factored form. Standard form can also be, you can complete the square to get it into vertex form. We're not going to focus on that today. We're going to focus on, given each individual type of equation, what's the easiest way to find the vertex. So, there are three different forms. Nope. We have a here out in front of our x minus h squared in the graphing form. A is also out front here, although that's only if it's fully factored. If it hasn't been fully factored, you may see it in one of these. The a value is what this first leading term would be if you multiplied the entire thing out. So that can be a little bit tricky with the factored form. And then a in standard form is still just a. It's the number that's in front of the x squared. Starting off, the vertex in vertex form. This is my favorite. The vertex in this particular one, so if I have, and this really doesn't matter, the vertex here. Let's say the vertex here is the point 1, -3. That is, in this form, the point HK. So in this equation, the h is our x value for our vertex, and the k is our y value. So x value and y value of the vertex. I'm going to erase those in a sec, so that's not the nicest way to do that. So going a little bit backwards, the hk is the x and the y of our, let's say, the vertex. Okay, couple things to note with that. No, I'll talk about it in a second. Sorry. The a value right there, that's our stretch factor. It's not quite the slope or growth factor because it changes, but it does have an effect similarly to the slope, just not exactly the same. Basically tells us how fast or slow we're going up from our vertex. So we'll look at a couple of examples and that'll help. So the first thing we need to look at is what each of our values are. So remember, we've got y equals a times x minus h squared plus k.
Yeah, of course.
So the a value on number 1 is -2. And in a little while, we'll talk about what that value does to the entire graph. Next up, we have our h. We'll do that in a different color. Our h and our k. Now, a couple things. You have to be careful with negatives here. So if I have x minus h squared plus 6, whoops, plus k, in this case, if I just take out the h and I put in a 5, then I have the same equation up there. And if I just take out the 6, sorry, a little discombobulated. If I just take out the 6, or the k, and put in a 6, then I have that exact part right there. Drop down the -2, that doesn't have an impact on your vertex. So what that means is my vertex here is the point 5, 6. Now, the reason negatives tend to confuse this is because this is an x minus. So there's a negative there. So if I have a situation like number 2 where it says x plus 8, what that means is that I had, if I'm writing it out not simplified, this would be y equals x minus, that's the part from this right here. And then my h value would be -8. So this part would reduce to the x plus 8. So what that means is my h for my vertex is -8. And then now looking at the second part of the equation, the k part, normally we would have had plus k. So what we're going to have instead, if we were to write this all the way out, is plus a -10. So that means our k value is also negative. So basically what that comes down to is that the k value is pretty much what you would think it is in terms of sign. If it's -10, it's -10. If it's plus 6, it's a positive 6. But the h value, for a lot of people, confuses them because they forget that it kind of flips. If it's x minus something, that vertex has a positive x. If it's x plus something, that vertex has a negative x. So that is the vertex form. Hopefully I didn't make that more confusing than it needed to be. So finding the vertex from the factored form, what we want to look at here is what this looks like on a graph. So if we have our two x-intercepts, here we're at -2 and +3. Now this is going from factored form, so this is our second method of finding the vertex. We're also going to have what's called an axis of symmetry going straight down the middle, and that's where we're going to find our vertex. So to find what x equals right here, I need to know what this value is. And on this particular graph, you can probably guess that it's 1/2, but I do want you to be able to find that mathematically. So what we're going to do is we're going to average those roots. Roots and x-intercepts are used interchangeably. So if you hear me go both ways, that's the same thing. So I'm going to take, for my h value, and my hk, remember for the vertex, is the first root plus the second root divided by 2. The divided by 2 here is because anytime you're averaging numbers, you divide them by how many you have. So if I have 2 numbers here, I'm going to divide by 2. If I had a third number here, it wouldn't be a parabola, but I would divide by 3 to average them. So if I equal that over, -2 plus 3 is going to give me a +1. I'm going to take the 2 over, so 1/2. So right there, that axis of symmetry is at x equals 1/2. That's also my h value for my vertex. Then, to get my y value, or my k value for that matter, I'm going to plug in, so I'm going to put in parentheses, that's my x, and that is my y for the vertex. I'm going to put in that x equals 1/2. So k, or y, equals 1/2 plus 2 times 1/2 minus 3. So I took my original equation, x plus 2 times x minus 3, and I plugged in my x of 1/2. So 1/2 plus 2 times 1/2 minus 3. So I'm going to do 2.5, or for simplicity, we'll go 2.5. And then 1/2 minus 3 is going to be -2.5. And then to multiply those out, is -6.25. And that is my k value. So my vertex from the factored form is the point 1/2, or 0.5, -6.25. And you can kind of see that on the vertex as well. Here's -6. The vertex is just slightly below that, about 1/4 of the way. So that's my vertex at 0.5 and -6.25. So that's factored form. Whoops. So to practice, what I would do if I were doing the, whoops, I don't know why I have a 6 on there. If you were watching this video, I would suggest that you pause it and try to do these on your own, and then I'll go through the steps, or I'll show the steps. So here, if we have x minus the root, again, this is a place where negatives happen to make a place where negatives cause an issue. So if it's x plus 5, that root for that one is -5. And that root is a +7. So basically whatever makes that 0, that set of parentheses 0, is your x-intercept when you're in factored form. So I'm going to get my h value, take -5 plus 7 divided by 2. -5 plus 7 is 2, divided by 2 is 1. For the k value, I'm going to plug that back into my original equation here for x. So I've got 1 plus 5 times 1 minus 7. 1 plus 5 equals 6. 1 minus 7 equals -6. You may start to notice a pattern here. Once you multiply those out, we get -36. So my vertex is 1, -36. For the second one, this 3 does not matter when you're finding your h value. It will matter when you're finding your k, so we'll talk about that in a few minutes. First off, my root here is going to be 4, and my root here is going to be -6. So let's average those to get our h value. 4 plus -6, or 4 minus 6, whatever your preference, divided by 2 equals -2 divided by 2, which equals 1. To get my k value, I'm going to take the original equation, so 3, don't forget that 3, that often gets forgotten. 3 times 1 minus 4, whoops, times 1 plus 6. So I end up with 3 times -3 times 7. Something doesn't look quite right there. Equals 3, whoops, equals -9 times 7 equals -63. And I think something went wrong, so hang on. I caught it. Way back up here. This should have been, this is a +2, and for some reason when I pulled it over, I wrote a -2. So I need to get rid of that. And that makes that value -1. So then, when I do this, sorry, when I come back here, I need to change those to -1s. And then we'll fix all of that stuff. Okay. So -1 minus 4, that's going to give me -5. -1 plus 6 gives me +5. By the way that I knew I had made a mistake was that once you put your numbers in, you should have the opposites of the same thing. -5, +5, 6, -6, and that happened on the page before too. So then 3 times -5 equals -15, times 5 is -75. So there's our vertex from factored form. Last one we're going to do is using the formula when we're in standard form. And my standard form is incorrect. Bx plus c. Okay, so my apologies. This is going from this particular form, so it's not factored. You have nothing in parentheses. The a value, for those of you who may or may not recall, is always the number in front of the x squared. The b value is always the number in front of the x, or the coefficient for the x squared and the x. The c is the constant. It's the one that's by itself with no variables with it. So that formula is x equals -b over 2a. And as I've been doing so far, this is x from the vertex. You don't know what I'm pointing at. This is x from the vertex. So I'm going to go ahead and write it as h. So your h value is -b over 2a. So we'll do a couple of examples of that. Similar as the last one, once we have that h value, it's just plug whatever you have back into the equation to find a value. So on the formula here, I don't like it written like that. I just couldn't type in a fraction at the time. -b over 2a. So here, if we're going from y equals ax squared plus bx plus c, in this case, a equals 2. This should look fairly familiar from the quadratic formula. B equals 12 and C equals 13. It works the same way. It's based off a lot of the same stuff, same math. Okay, so I did it again. H equals -b over 2a. So H equals negative, and then our B value is 12, so I'm going to put in 12, divided by 2 from the formula, and our A value is also 2. Then I just simplify. -12 divided by 2 times 2, which is 4, so H is -3. Our K value is going to be 2 from the equation, and then I'm going to plug in -3 for x squared plus 12 times -3 plus 13. In simplifying that, you want to square first. Negative 3 squared. Anytime you square a negative, it's always going to be a positive. So negative 3 times negative 3 is 9. If you put it in your calculator without parentheses, oftentimes it will give you negative 9, so be careful. I'm going to drop everything else down to just go step by step here. All right. 18, my 2 times 9, minus 36, plus 13, negative 18, plus 13, is negative 5. So that is my k value, or my y value for my vertex. So I have a vertex here of negative 3, negative 5. Next one, next example anyway. A here, negative 3, negative 24, and 8. Whoops, c equals 8. We don't need c in our formula, obviously, but not a bad habit to get into. So h equals negative 24, divided by 2. A is negative 3. So now we need to simplify here. Negative, or a double negative 24 is a positive 24. 2 times negative 3 is negative 6. So this is going to give us negative 4 for our h value. Our k value, negative 3 times negative 4 squared, minus 24 times negative 4 plus 8. Negative 4 squared is 16. Drop everything else down. Negative 3 times 16 is negative 48. Negative 24 times 4 is 96. Positive 96, and then plus 8. So this is going to give me 48. Drop down the plus 8. Whoops. And I have 56. So my vertex, my xy for, or my values for xy for my vertex, also known as hk, negative 4, 56. So that is standard form. So, pattern in a parabola. This is the standard y equals x squared parabola. If there is no a value, or an a value of 1, then the pattern it takes goes out 1 and up 1 in both directions, out 1 and up 3, out 1 in both directions, up 5, and what you would find is this pattern here would go up 1, up 3, up 5, up 7, up 9, so on and so forth. That's with a standard. And you can also see that if I have just y equals x squared, and I'd make a table, and I put my vertex of 0, 0 in the middle. If I do negative 1, negative 2, 1, and 2, then I can just plug in numbers into x. It's always good if you're making a table to put your vertex in the middle. So negative 1 squared equals 1, as does 1 squared. Negative 2 squared is 4, positive, that's 4. So that's what, that's where these points are coming from. And it just happens to have that 1, 3, 5 pattern. Now, where A impacts that, and I'll jump back to, if I have, so this one, A is 1, and the pattern was 1, 3, 5, 7, so on and so forth. If my A value is 4, this is going to be 4, this is going to be 12, and that's going to be 20. So each part of that gets multiplied. And if you're ever in doubt, you can always just use a table. Find your vertex, plug in 2 numbers below it and 2 numbers above it for your x values, and then plug it into your original equation to find the rest of that. So hopefully that provided a helpful, so if we're looking at a parabola with a different growth factor, we're going out 1 and up 2, out 1 and up 6, and out 1 and up 10. What that did to our other parabola that had the out 1 and up 1, out 1 and up 3, this is a really bad drawing, and out 1 and up 5, it took each of those numbers, that 1, multiplied it by 2. 3 times 2 gives you 6. 5 times 2 gives you 10. So that A value multiplies each part of that pattern and I'm just going to say the 1, 3, 5 pattern by A. So if I jump back